Guys and girls, it's Noah time!
Alright, so last time we didn't get a chance to finish this question. So guys and girls, let's get cracking on this one. First thing, I'm going to isolate cos 3 theta, which gives you cos 3 theta equals to -1 over 2. Okay. Right off the bat, you can use a quadrant system. Quadrants. And I'll give you a few minutes to figure out what quadrant you're in, draw your special triangles, and tell me what your theta is. So guys and gals, I'm going to pause it. Alright guys and gals, so cos is negative, quadrant 2, and 3. See? I keep it simple, nothing too bad. And all we're going to do is just label your one of the triangles. You don't have to label 2, just one of them. So -1, and again look, I'm using negative. 2 root 3, so this is pi by 3. So right up the bat, I know, I should have said this, let x equals to 3 theta. It just helps me out a tad bit. So this question becomes cos x equals to -1 over 2. So my theta, now we're going to solve for theta. So x equals to 2 pi by 3. And I have one more solution to work with. Randy, what's the next one? 4 pi by 3. Okay. If you use those as your true answers, you're wrong, because that's x. My goal was to find theta. So we sub it back in and find theta. So we go 3 theta equals to 2 pi by 3. That's one of them. And 3 theta equals to 4 pi by 3. Guys, gals, take a minute. Solve for theta. Nothing too bad. And once you finish, so all I'm going to do now is solve for theta. So theta equals to 2 pi by 9. And 4 pi by 9. I have two. These are called my true solutions. Okay. But the question says general solution. So we're going to take my true solution and we're going to create a general solution for that. So your general solution is going to be 2 pi by 9 plus n period. My period in this case is 2 pi by 3. 2 pi by 3. Okay? And you should really go n, e, I. It just means n is an integer. You cannot have a decimal place for n. That's what that actually forbidden thing says. N cannot be a decimal number. Now, I go 4 pi by 9 plus n 2 pi over 3 n, e, I.
So now we gotta find.
Guys, gals, these are called your general solution. Now you have to find all solutions, and you can probably predict how many solutions there are. 6. So guys, gals, to find all solutions, we start with 2 pi by 9 plus 2 pi by 3. Now, a lot of students will ask me, so what's the maximum you can have? Because really, I want to know, your max is 2 pi. But if I look at 2 pi by 9, if you want to know what the maximum numerator is, you take the 9 times by 2. And that gives you 18 pi by 9. This is called your max. You cannot have anything more than 18 pi by 9. Okay? Or 18 pi by 9, yep. So now we keep adding. Make sure you have a common denominator. And we go 2 pi by 9 plus, so that becomes really 2 pi by 9 plus 6 pi by 9, 8 pi by 9. Voila. So we know it works. This works. This works. We're going to add in another one. We're going to add in 6 pi by 9 again. It gives you 14 pi by 9. this works. Okay. If I added another 6 pi by 9, it goes outside of range, so it doesn't work. So here are my first three. Second three. 4 pi by 9 plus 6 pi by 9, 10 pi by 9.
Are these all equal to theta?
Yep, they're all equal to theta. And I'm going to just do another shortcut. My other answer would be 16 pi by 9. Hey guys, gals. Voila. This is how we find all solutions. Any questions on this before you start your quiz? Because I kind of roughly ended. Question? 2C? Homework? So look at your homework, please. Page 83. 2C. Page 83. 2C. Which one is C? This one? Cosecant? Ah. So 2C is going to be cosecant 2x equals to -1. Now, would you agree cosecant is the same thing as sine?
Yeah.
So let's rewrite this using sine. Sine 2x equals to -1. I see 2x, I don't like it. I'm going to use a let statement.
Let theta.
Yep. Let theta equals to 2x. So this becomes sine theta equals to -1. There's only one way to solve when sine equals to 1, -1, or 0. You got to graph it. Okay. Draw a quick sketch. Okay. I just want to see what a quick sketch looks like. And equals to -1. Oh, look at that. Right there. Question?
It's from negative pi to pi, don't we?
Ah, good question. Your restriction is from -pi to pi. Yep. So, to do this, what we're going to do is imagine what it looks like backwards. So where's it equal to right here also? So what is this point right there? -pi/2. So this one, theta, equals to -pi/2. Sorry, what? Oh, it is, but in a second. So, but that's theta. I'm not looking for theta, I'm looking for x.
So
Now we just sub it in. 2x equals to -pi/2. X equals to -pi/4. That's my first true solution. Okay. And then I would keep on adding period to see if it falls within the range or not. And that's how you do that, basically.
So which one's the period?
The period is pi. Because your general solution is -pi/4 plus n pi. That's called your general solution right there. NEI. Ni. And if you say how, that means hello in Chinese. Ni hao. Okay. Seriously, ni hao is hello in Chinese. Okay. Guys, gals, voila.
Oh, how about 3F?
3F? I'm going to see that. 3.
It's one of those common solution questions.
Wow. Wowzers. Good question. 3F. How many solutions are there? I was about to use this on your quiz for the weekend, but I decided not to. B sine AX equals to B says A is greater than 1. If I solve for sine, would you agree sine AX equals to B over B, which is equal to 1? Sine AX equals to 1. If I draw a quick and dirty sketch, how many solutions do you have for one cycle? 1. There's only one solution allowed. So I'm going to write this down. Each graph has one solution. You can't have, then you have no solution. So each graph has one solution. So now, in other words, A is equal to 1, you have 1. A equals to 2, you have 2. So how many solutions there are in total? So for this one you have A solutions. We don't know what the value of A is. It just means you have A solutions. If A is 5, you have 5 solutions. If A is 10, you have 10 solutions. Because each graph only has one solution. Question?
So same thing with sin ax minus b equals a.
Yep.
Then w equals 0. Would you be like two solutions then?
Yeah, the first thing.
Okay, so hang on. Sine AX. Say it again, Aaron.
Sin ax
Minus
minus b
B
equals b.
equals to B. Then that is, no. Then sine AX.
Plus b.
Wait, this is plus B? Okay, so that means sine AX equals to 0. So where is sine equal to 0?
3 places, 0.
2 places, 1 and 2. So therefore, each graph has 2 solutions, so you have 2A solutions.
But you just said that.
I know, I thought you just said it only need one solution.
Oh, I thought if you have something, let's say, up here. Up here somewhere, that means you have no solution. Let's say sine AX equals to 1.6.
No.
Then you can't have any solutions whatsoever. Okay? Alright guys and gals, what we're going to do is we're going to put all this away and let's get crack-a-lack in our quiz. I'm going to show you why. See, it says sine AX equals to 0.5. And the key, just draw a rough sketch. 0.5 somewhere here. See? Hits it twice. Each graph has 2 answers. So you got to write this in English. Each graph has 2 answers. Now, how many graphs are there? I don't know how many graphs there are because I'm not given the A value. So how many solutions? So in reality, there are 2 A solutions. This is one of those theory. Question? Oh, yeah. Zena, can you turn off the lights for me, please? Thank you.
What's this from last week?
Quiz there from last week. I'm going to give it back to you. I just marked and updated everything. If you check N grade, everything should be updated and everything. Yeah. Some more bad news for you guys and gals. Today and tomorrow after school, they forbid me from staying behind again. I know. Like I just because it's on a bell-to-bell schedule. So in other words, teachers says the parking lot has to be cleared by 3. They forbid me from staying behind.
So anything after school is not going to happen?
No, not for a while. Not until this whole strike thing is over. So I'd love to say, that's why if you go online, put on a question on and grade, I'll help you out. But a few key things. Today is actually my favorite part of grade 12. This is called trig proofs. I mentioned to you that there are 22 formulas you got to remember in grade 12. You've learned half of them already. I'm going to teach you the last 10 today. Not today. I'm going to teach you the last set in about 3 days. Okay. We are going to finish trig proofs by... Ooh. Yeah, because of the strike thing. It set me back a bit, but I'll figure things out. Guys and gals, it's Noah time. And because it's Monday, you get a brand new line. Or not Mondays, no, Thursday. New week. 1, 2. You guys waited a long time for this. Some of you had dreams about this. Say, Miss Snow, I dreamt you told me what the next line is. This is what you had last time. Here are your 3 lines for this week. 1, 2, 3. 3. You got 3. So you gotta wait till June before you finish the picture.
Is it your girlfriend?
My what?
Is it your girlfriend?
My girlfriend? No, it's just.
When you come back after spring break, you get like.
Oh no. You just get a few more lines. Here, it's how to do trig proofs. Okay, trig proof is basically the whole concept behind trig proofs. Now, every year I taught this, every student said this is one of their favorite units, trig proofs. Okay? The whole concept behind trig proofs is proving left side equals to right side. That's the whole concept. You know if you did it right or wrong right off the bat. Equal right side. Because there's no tricks. Now, I'm going to give you just a very, very quick example. I say 2 plus 1 equals to 3. A lot of you look at this and say, hey, this works. Because the first thing we're going to do to show you how to set up proof is we're going to draw an imaginary line right down through the equal sign. Separate left and right. I go 2 plus 1. Instead of writing on the right side, I'm going to write on the bottom. So 2 plus 1 we know is 3. Look at my right side. It's 3, see? Left side. And at the end, we're going to say LS equals to RS. So we know 2 plus 1 does indeed equal to 3. That's what the trig proofs is. Very, very simple. Nothing too bad. Okay. Now, in order for you to do trig proofs, you're going to need to memorize some formulas and basic things. I've taught you sine theta, cos theta, tan theta. Those are the basics trig. 3 basic one. Now, you're going to work with cosecant theta. But instead of writing as hypotenuse over opposite, all you're going to need to know is cosecant is 1 over sine theta. That's all you need to know. Guys, gals, fill this in. Secant theta and cotangent theta. Take a minute and just fill that in on your own. So this is 1 over, Paul, what is it? Cos theta. And Robert, cotangent theta is 1 over tan theta, which is correct. But cotangent is a bit unique. We're going to rewrite this using sines and cos only. So this is actually cos theta over sine theta. Okay. So for now, I want you to know that cotangent is really cos over sine. And tan theta, what you really need to know about tan theta? Tan theta really is equal to, you know it's opposite over adjacent, but for now, I want you to learn it as sine theta over cos theta. Okay, keep it simple. So tan theta equals to sine over cos. So there's a little joke that helps you memorize this stuff. I'm not sure you heard this joke before. So one day, cos was lying on the beach. All of a sudden, sine comes along, steps on cos. Cos says, "Hey, do you mind? I'm trying to get a 10." Ha 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 ha. Oh. It's in the morning, I guess there's no laugh. So guys, just remember that joke. So cos was lying on the beach one day.
Are you recording?
Yeah, it's a great joke. Sine comes along, steps on cos, and cos says, "Hey, do you mind? I'm trying to get a 10." So that's how you remember it. Tan is sine over cos. Now the key to doing this, I'm going to give you a few minutes. I want you to burn this in your head, memorize these formulas. So one more thing, the key to doing trig proof, the key to trig proofs is to convert everything to sine and cos. You cannot work with tan. You cannot work with cotangent. You cannot work with secant. Everything has to be converted to sine and cos. For example, I'm going to pause it, and I'm just going to, here's your question. I want you to prove it. Again, the key is to convert. So I'm going to give you my first example. Keep it simple. Example 1. Cotangent x tan x equals to 1. Somehow you got to prove that those are equal to each other. Now, first thing, I see an equal sign. So what we're going to do, we're going to draw line right down. Right down the middle. Okay. Would you agree the right side I can't do anything to it? So let's just work with left side. Left side, I see a bunch of cotangents and tangents. You cannot work with these, so convert everything into sines and cos right now. So all I'm going to do is just keep it simple, convert it to sines and cos. Irish, cotangent. What is cotangent? Oh, whoa, no. Cotangent. Cos over sine. So I'm going to rewrite this as cos x over sine x. Okay, I use brackets. Jasmine, tan x. See? Sine x. I don't even have to think about it. I just look at it and I know right off the bat. Bam, bam. And I just convert. I didn't do anything hard. All I did was convert. Hey guys and gals, when you multiply this out, look what cancels out. Everything cancels out. If it cancels out, look, cos, gone. Sine is gone. It doesn't mean it's a 0. It just means you're left with a 1. Hey, look, 1 equals to 1. So we say OS equals to RS. And that's called trig proofs. I know I did it right because my left side and right side are exactly the same. I would never give you a question where you can't prove it. It's always you could prove it. A bit more challenging. Let's see if you can figure this one out. Secant x cosecant x over cotangent x equals to secant squared x. I'm going to pause it, walk around, write a few things down. You cannot move anything around. Star. You cannot move stuff around. So, for example, I can't bring cotangent x to the right side. It doesn't work. You got to leave it the way it is. You cannot move stuff around. First thing I like to always do, draw a line right down the middle. Just right down. And keep it simple. Secant squared x, you can rewrite this as 1 over cos squared x. Okay? Not bracket squared, but I just go as 1 over cos squared x. I'm going to pause it. So I look at the left side. I see a bunch of secant, cosecant, and cotangents. I can't do anything, so I'm going to convert. Harpreet, secant x equals to what? 1 over cos. Now instead of writing x, I'm going to be a bit lazy for now. I just go 1 over cos. Okay. Cosecant. Abraham, what is cosecant? 1 over sine. So I'm going to be a bit lazy. Over. Kieran, cotangent. Cos over sine. I'm going to show you my first trick of working with fractions. A lot of people look at this and say, so how in the world does this equal to this? They have nothing in similar. Now, a lot of you are stuck because you try to look at it all in one big shot. The key to working with fraction is to separate. I want you guys to write this down for me. We're going to write down top. Okay? It will help you out in the long run if you follow this technique. 1 over cos. See, I'm just working with the numerator right now. Don't look at the denominator. You can confuse yourself. Simplify this right now. 1 over cos times 1 over sine. You're going to merge it together to get one fraction. So you get 1 over cos sine. Okay. Should be cos x sine x. That's on top. My bottom is exactly the same. Nothing changes because I can't simplify the bottom in any way. Now, write your new top over your new bottom. It will help you out a lot. It makes things easier. Okay? Gives you 1 over cos sine over cos over sine. Back in grade 8, you were taught how to divide fractions. You multiply by the reciprocal. So go ahead and multiply by the reciprocal right now. So you get 1 over cos sine times sine over cos. Hey, start canceling things out. Sines will cancel very nicely. Do it. Do it. Okay. The sines cancel out. Oop, I kind of used too many rooms. And if I look at this, this becomes now 1 over cos squared. Hey, if you look at the right side, it's also 1 over cos squared. Both sides are the same. So LS, and I always write equals to RS. Now I kind of made a mistake in that I shouldn't have written stuff on the right side. Okay, so all this stuff should have gone on this side. Guys and gals, that's how you prove trig. One last question, and that's it for today. We won't have time. I'm going to have you tomorrow. Actually, I can give it to you. Good luck with this one. Show me full work. And I'm going to be honest, all this is fractions. How well can you work with fractions? I'm going to modify this question a bit. Sine x plus tan x sine x equals to sine x cos x plus sine squared x over cos x. I modified that question a bit from your book to make it a bit more challenging. Prove to me left side equals to right side. I'm going to pause it. Some of you have the weirdest approach to doing this, but I'm going to be honest with you. Here's a proper way of doing this. What I'm looking for on your exam is, first of all, I need this big middle line because you want to separate left side from right side. Without this middle line, can't separate left and right. Now, some of you decide to work with this side. The right side, you can't do anything because everything is in sines and cos already. If I look at the left side, there's one thing that's not in sine and cos, and that's this tan x. So all you're going to do is rewrite tan x using sines and cos. This is going to be sine x plus, Ryan, what's tan x equal to? Sine x over cos x. See? All I'm going to do is I keep it simple. Sine x. Now I'm going to simplify the left side. Sine x times sine x is sine squared x. So this becomes sine plus sine squared over cos. Agreed? If I want to simplify the left side, there's a denominator here, which is 1. Come up with a common denominator. Cos. So this now becomes sine cos over cos plus sine squared over cos. Hey guys, gals. Two fractions with the same denominator. Mix them together. You have sine cos plus sine squared over cos. See? Left side, right side. And the key is you work on the things that are not sine and cos. That's how you approach this question. Left side equals to right side. Voila.
But you could have made the other side equal that equation, couldn't you?
This side equal to this side? In more challenging questions, it won't work. It works, but you're screwing up the whole thing. Because if you follow that technique, I need to train you how to do it the right way. Follow this technique. It will make your life easier in the long run. Your work. Page. 87. Number 1 to 20. All the answers, if you look at the answers, is in detail for you. So if you're lost on something, Look at the answers. It's all there.